Hi everyone, welcome to DevFest 2020, day 2 of Flutter Track. My name is Devin Joshi and I'm a Google developer expert for Flutter. I work at Stream as a Flutter and SDK developer. Yesterday, Pooja and Kamal explored a lot regarding Flutter architecture, basic UI, and creating the basic pages of the TMDB flow. Today, we extend this app to make it even more feature complete by fetching real world data as well as making it responsive and making it work for multiple platforms. With Flutter starting to expand to multiple platforms, multi-platform UI and multi-platform things are a thing you need to consider. Since building for mobile will not help in building for web, and we need to manage everything at once. So today we are going to think of a more feature complete app and not just a mobile app. So today we're going to extend the app we took earlier yesterday, and we are going to make it, we're going to implement real world data using an API. We're going to basically by understanding our source of information, learning to fetch what we in Flutter, and finally using that data to create widgets and UI in Flutter, best practices, and along with that. Later on, Pawan will also cover animations and running the app on multiple platforms and deploying the app and so forth. So with those things covered, you should have a good idea about how to make a whole complete, feature complete, multi-platform Flutter app. So let's start. First, we need to understand the source where data comes from. TMDB offers an API for you to use to build your own applications, which need real movie data without having to aggregate it yourself. In this first section, we will try to understand why and how we use the TMDB API. The API itself is vast, and we will try to create an example, but other things work very similar to it. Once we understand how we do it here, it's pretty much an extension for everything else. And even doing this one thing will help unlock a lot of the things we learn in Flutter as well. Okay, so now we'll take a look at what the current situation is what the state is with the current day 1 app. The data in the app itself is hard-coded. We covered building the movie cards that would display movie posters. In the current application, obviously that is hard-coded. And as much as we would like this man to be the poster of all movies, we just can't do that. We need to fetch real-time movie data and display it in sections, like the trending section. Along with this come other issues like when and where do we want to store that data? Because there's a lot of approaches, and as we will go on to see, it's just not as simple as it looks. And now, for example, do you want updates? Do you want streams of data? Stuff like that. So we will try to make a solution to that, but the main problem we're currently trying to solve is fetch the data in the easiest kind of way and connect our app to the network to make it a real world app. Okay, so the API itself we're using is the TMDB, or the movies database, and with every single API, they come endpoints. Endpoints allow you to fetch certain kinds of data. They may be something like trending movies or trailers or any kind of stuff that goes associated with movies for TMDB, but other things with other APIs. Now, if you see, what we are trying to do in this example is get the trending movie section connected to our app. In this way, what we need to do is that we need to first retrieve that data. But before we retrieve that data, we need to understand what the data consists of. In some conditions, we can also supply parameters from our side, such as the time window required for trending movies. But before that, we also need a base URL. So first, with the endpoint, we say, okay, we want the trending movies. With the parameters, we say we want the trending movies between, let's say, now and 1 week ago, or now and 1 year ago. So because the movies change, the trending movies change according to the time defined. So now, with the endpoint of the API supplies us data in JSON. Now, JSON is a good format, but it does not allow us to use it directly in the app. And we first need to pass that. Now, In the endpoint itself, it also carries so it will carry the data of every single movie that we're talking about. It might do things like movie names, rating, release date, and the movie ID. For example, if you need to get more information with regards to the movie, now we know that now we know where our data is coming from. We need to learn more about how to fetch it. This was the endpoint fit of TMDB for fetching trending movies. And now that we know that what data we're getting, let's see what we need to do. So now we need to look at fetching network data in Flutter. So after looking at the endpoint, we have an idea of what comes from the website to the app. Now we actually need to connect, retrieve, parse, and use the data that we talk about. For this, we need to go through how to connect our app to the API itself. So that means we need to connect our app to the network. In that network connection, we have multiple steps, and we will we will go through it. But network connection is a fundamental thing that we need to learn about, because pretty much every single app of Flutter app really uses it. Okay, so here are the steps to fetch the data required. We'll go through them in more detail, but the first is create a data model. Second, use the HTTP package to connect to the API itself. And the third is convert the JSON into a data model instance. The data we retrieve from the TMDB API will be in a string format, and we cannot use that directly. Ideally, we would have a class that has all the aspects of the movie with the appropriate data types, which would be a main movie data model. But even before we fetch that, we need to actually connect to the API itself, which we do using HTTP. In that case, first we connect to the HTTP, then we parse it. So in orders of development, first we need to create a data model, which basically says, okay, so these are the characteristics of the data model. So let's see that next. Okay, so this is an example of the movie data model, which you will see contains all kinds of stuff about the movie. Since we know all the fields of the TMDB trending movies endpoint, we can create a proper data model based on it. This data model converts a string or map into a proper class-based representation, and also holds functions to convert it to and from the JSON format. As we see here, the trending movie class holds everything required for a movie, and now that we have a data model, we can focus on retrieving it. A thing to note is that while we need these data models in nearly every kind of app, there's no need to do it manually. And there are various tools online, such as QuickType.io, to do it yourself. You can also create them using code generation in the Flutter app itself, which will save you a lot of time. Now, when it comes to JSON parsing, it is a very it is a thing that needs to happen very often. So there's lots of ways to create this model. So just because something has a lot of fields doesn't really mean you have to type all of that yourself. You can use QuickType, you can use code generation, all sorts of things come to your aid. Step 2 is actually connecting the HTTP package. Now, the HTTP package is used to fetch data from the URLs. To fetch data, we use a base URL of the website, which would just be tmdb. Whatever the website name is, and then maybe an API version, and that's it. So we use a base URL of the website, which hosts the content, as well as the endpoint of the section. Our section is the trending section, so we would use a trending section endpoint. Most APIs also ask for an API key as a parameter, so usage can be attributed to your account. Since we are simply fetching data, we use the get method of HTTP. We just need to fetch all that movie data, and we just pass along the API key as a parameter. Since there's nothing TMDB needs, we can just go with that. We don't need to do a post or a simple or anything else, right? So an HTTP request takes an indefinite amount of time. Hence, we need to await the results of the HTTP call. The response received now also has a status. A 200 is an okay, but again, there's 404, there's 403s, and there's all kinds of different errors that come in. and we need to sort them out. And here we can also just receive, if we receive some kind of a 200, or if you receive some kind of error as well, we can pass it, and then we can supply the data required, or we can just supply that either a null or basically something did not work out. So here we connect to the HTTP in this way, and basically we now need to convert this response into a required movie classes to use it in the app. The HTTP package itself does most things out of the box, but in addition to HTTP, you can also try out other packages like DIO, that's DIO, that make things much easier, and overall this gave you a plethora of features as well. So if you want more functionality, you can also try that out. But right now, till this point, we have connected to the HTTP server. We have a data model in place. Now, the main thing we need to do is take this data and convert this into usable class instances to use in our app, because we can't just use raw strings or even a list or a map of things right now. So the third step is finally, now we've gotten all this data. This data, we know that we have connected, we have retrieved that data. Now we need to convert it into instances. So after we fetch the required data, we finally convert it into the data into the required movie list. To do this, we first check, right, if the data retrieved is okay. So if it's a 200, then that means it's okay. We can go ahead. If it's not, then it really depends upon your kind of use case, upon like what you want to do with a failed request or stuff like that. So since the movies list we need is under the results key, we can just simply use that part. We don't need to create a model for the entire response. The data model also houses the from JSON function. So with the earlier slide where I showed you the data model, that didn't have all the other utility functions which were for to and from JSON, but usually it comes attached to any class which comes with that, because so that you don't have to have any other utility method just to switch data to and from. So the data model, they just houses all of those things. And after doing this, we finally have a usable list of movies. Since this function is asynchronous, the function itself returns a future and not a synchronous list of movies, right? So now because we don't have a synchronous list of movies, when we can't really directly call this in the build function when we are building a widget, because that really doesn't, because the function will wait until it retrieves all the data, but it will not complete until the entire list is retrieved. Whereas the build function, it will not wait, because we cannot stop the UI from building, or else the app will give an ANR, which will just stop the app in its tracks. So we cannot wait, but obviously the network call has to. So we will have to figure out something that melds these things, which is a synchronous build function and an asynchronous network call. So let's keep that in mind for now. Okay, so till this point, we have all of these things pretty much carry over across frameworks. There's nothing that we're doing very differently from any other framework, but here is where that splits. And here we go into things that are mostly Flutter specific. The question remains, how do we turn the fetch data into a widget? One thing to note here is that there's no silver bullet to this question of fetching data and displaying data. It depends upon several factors, and various methods of state management may try to do it differently. It also changes if you need to cache data in a SQLite database, for example. For now, we'll be using a simple solution, but I would recommend checking out all other methods if number of calls, offline data persistence, or different state management methods are involved. Flow of data and where it is retrieved changes drastically when considering different methods, because every single thing really has a different way of handling data, and where we call this network call really does make a difference when it comes to how the state management framework itself manages data, passes on that data, because all it is a way of managing asynchronous, synchronous calls. And for now, we'll use easier method, but I do recommend checking it out. So to display API data as widgets, we need two things. One, we need to fetch that data, right? We already have gone through that, but we need to fetch that data in the app itself. It's easy enough just to get a function running, but now where do you call it? That's the question. And the second, once you get that data, you need to build the widget, or you need to build the movie card or stuff like that according to the data you receive. In that case, you need to first fetch all the data and then second display it. So we need to do these two steps. And for example, in this app, we will fetch data every time a widget loads, for example. However, as your app size grows, you might want to look into some kind of data persistence if you do not wish to wake up to a large API usage bill, or stuff like that. Because sometimes what happens is when you call API endpoints and the API itself is expensive to call, then it becomes really hard when you're doing it every single time. So keep that in mind when you need something that might be an expensive operation for an API endpoint, suppose. Second, we need a good way to turn the data into UI elements, as well as handling cases, right? So, for example, you have request failures, or if you have network issues or stuff like that, it just simply does not it simply does not work, because you would need to write multiple cases. So we need something that handles all of these success, failures, synchronous, asynchronous things efficiently and in one place rather than in 10 different places. So the hard-coded version is this, where we just have a movie card item. We simply supplied a dummy URL to the card for it to work manually. Now with new data coming in, we need to have a list built with it, but we also need to account for loading times, error conditions, without having to do a large number of steps. This is where Future Builder comes in. Okay. Future Builder is a widget which builds a certain portion of the widget tree based on one future. A future is returned by any asynchronous function. In our case, the network request takes an undefined amount of time and may or may not complete. The Future Builder runs the future in question and provides a snapshot to a builder function. The builder function is what actually builds the widget in question, not just the list of movies, but also loading indicators when things are loading, or error messages and stuff like that. This allows us to neatly separate all the cases while keeping the code to a minimum. A thing to note is that Future Builder should be used to display fully loaded things, and do not try to mesh several different Future Builders together. But with our code, we are now fetching, parsing, as well as displaying the data in one neat packet of code. With similar to Future Builder, there's also other things like Stream Builder, Animated Builder, and stuff like that, which also build upon every single update. So Future Builder helps us solve all the main issue of actually trying to handle many cases, fetch the data, handle the synchronous build requests, and it automatically builds it on its own. But finally, we actually have your to watch list is basically now ready, because with Future Builder, we could fetch the data, we could easily handle all the cases where it did not work out, and we can finally handle the case where it did. So in the end, we now have a trending movies list displayed in real time, which you can officially go and binge. Similarly, we can also connect all other elements to the TNDB API and make a fully functional clone of the website. Up next, Pawan will talk about some cool animations, running the app on different platforms, and more instructions on deploying the app itself. Okay, so that's all from my side. Thanks for watching, and you can find me on various places such as Medium, where I've been writing since Flutter was in alpha, and Twitter, where I post all things from random Flutter experiments to Flutter generative art. Both of them are honestly just all Flutter at this point, links to which are on the slide. So thanks again for watching, and over to you, Pawan.
Thanks, Devin. It was really wonderful explanation. And so we have already done the creation part of all the widgets for this particular application. We have also seen how to use Navigator to go to one screen to another. And we have also seen the API integration, which makes our app real. We have done most of the things, but is it enough, or can we do more to it, right? So yes, so hi everyone, this is Pawan Kumar, and I work at Frontier as a head of mobile engineering team. I also run a YouTube channel called MTech Viral, and I am also a Google developer expert for Flutter, Firebase, Dart, and Web Tech. So now let's talk about the web part of Flutter, right? Because we are talking about cross platform here, and when we talk about cross platform, then web is definitely one of the things which everyone wants to see and wants everyone wants to use, right? And when it comes to web, it's just not about normal app development. It needs more than that. It needs because on web people will be using mouse, touchpad and all those things. So how we can handle mouse events when we talk about web, right? So if you see this one, then there are a couple of widgets which we can use. So the first widget here is mouse region. Okay, so we can use something called mouse region. What it will do, it will give us that if our widget is entering like if our mouse is entering to that particular widget, or if it is exiting from that. So if we see the example over here, so in this slide you can see that we have a mouse region widget, and it has three different properties. Let's say on enter, on hover, on exit. And based on these properties, we can modify our application or our state a little bit of a particular. Let's say if we have a variable, we can change its state or change its value. And then we can do some cool animations as well, using these all these properties, and this will work pretty good on web. So if we see this, so another widget is there, which is listener. So first one was mouse region, second one is listener. Listener is another which can give us pointer events, right? But I'll still suggest, if it is possible, then we should use high level gesture detector. But in case if you need to use if you need more access, then you can just definitely use listener. So you can see this example. We have again on pointer up and down and all those properties which we generally get with like gesture detector as well, on tap down, on tap up, and all those things. So when you are targeting web, then these two widgets can be really really useful for you, and you can do pretty much good stuff with just these two widgets, and combining them with the animated container, transformer, and all these widgets, and that can give you cool effect. So for example, if you see our application, right? So in our application we are also using this as you can see mouse region widget. And what we are doing, we have a hovered property which is by default false. And once we enter to this particular let's say when this enter callback is there, then we can what we can do, we can directly check this hover to true, and then when we go to on exit, then we can make it false. And based on this hovered value, we are using an animated container over here. And what we are doing this with this animated container, we are actually setting the height based on that hovered value. Okay, like we are slightly changing the height. Okay, and what it gives is this. So if you see here, we get a really cool effect when you hover on a particular widget with this, like let's say trending page or trailer section, not page but the section itself. So why it is useful, because it gives user a nice feedback that okay, this item is what you have selected, or item is where you are. And also it gives your application a really cool way to represent, like this is a really normal thing which you see on every other web application. So Flutter actually makes it very easy for you to deal with these kind of things as well. Now let's talk about Flutter apps for everyone, because the whole topic of these 2 days presentation was this. And when we are saying that we are talking about Flutter apps for everyone, then what we mean is that we are gonna target cross platform. So cross platform is not just about a single platform, but many other platforms or major platforms which we are going to target via our Flutter app. So now let's see, if you really want to target all the major platforms, then what are the options and how we can like use them. Okay, so as a developer, I'm assuming that you might be using you might be aware about all different branches which are available with Flutter. So on Flutter, is as you can see in this slide, that we have a stable branch, we have a beta branch, we have a dev branch, and we have a master branch, right, or main branch, whatever you want to call it. So now when we are working on stable branch, because that is the like mostly people might be using stable branch, then we can as of now target Android and iOS application. But if you want to target web as well, then you have to use beta branch, right? And similarly, if you want to target desktop application, let's say Windows, Linux, Mac, then you can use either the dev branch or master branch. So this is what you have to do to make your application like available on all the major platforms. And that's just not it. Okay, if you, even if you do that, then also there are a couple of things which you have to make sure you are checking. So this is how it looks like. As you can see on the screen, that this particular app, our TMDB app, is running on all the major platforms. So you can see Android, you can see iOS, you can see Mac OS, you can see web, iPad, and similarly it also works on Windows, Linux, and yeah, other platforms as well. The only thing is that there can be few limitations to some of the platforms which are in beta or alpha. And there might be many plugins which are not supported. But yes, with every day which we are going through, there are more support added to these kind of libraries or plugins for let's say for Flutter for web, for Flutter for desktop. So yeah, it's just a matter of time, and we will see more and more libraries supporting these platforms. So when I say that you can go to these branches, you can check out these branches, and you can enable let's say for web, Flutter for web or Flutter for desktop, you have to also enable these features manually using some configs. Okay, so it's pretty easy. It's just a one line of like command which you have to enter. And if you want to know more about it, then you can check out my blog or article on this. And I'll also post this on Twitter, so you can check it out. Now moving ahead, let's talk about the main thing, which is responsive apps. I know many of us are kind of working on different sort of devices, and we want to support all the devices irrespective of their size, their resolution, their maybe you can say their orientation, whatever, right? So when we are saying cross platform, when we are saying that we are targeting multiple operating systems as well, then this thing becomes a very very important topic, right? To make our app responsive. So by responsive, what we mean is that it should work on any kind of device. It doesn't matter like if the size of the device is 6 inches or if the size of the device is 12 inches. So on all different screen sizes, it should work. On different screen resolutions, it should work. So for that, we have to make our app responsive. And to make it responsive, what we can do, right? So if you see here, we get a lot of classes and widgets by default with Flutter, which can help us in achieving this. Okay, which can help us in making our app more responsive. And yeah, it can do a lot of work for us. For example, let's take this example of media query class. Okay, media query class gives us media query data, and using media query data, we can get the current width of the window or current height of the window. So all of these things, we can get with media query data. Similarly, we can use layout builder, which can give us all the constraints, and using those constraints, we can write some logic. Let's say we have a breakpoint set for a particular device size, and we can apply some logic, and we can render widgets accordingly. Similarly, we have aspect ratio, fractionally sized box, and a lot other widgets. So we can use all these widgets to make our apps more responsive. But so if you see this example on the left hand side, we have this media query which we are using. So media query dot of context dot size dot width, by which we can get the width. And on the right hand side, we are using layout builder, And what layout builder is doing is basically layout builder is giving us some constraint, and we can check the maximum or minimum constraint, and we can do some work according to that. But it's not always very easy to do this, right? It's sometimes you will feel that okay, this is just too much, or you can just see that okay, I have to make a separate class for having different breakpoints, or you can say that if we want to have a responsive application, then we have to create some scenario where by which we can render some widgets, right? And this is kind of where third party libraries comes into the picture, or you can say your own configurations which you can do separately, it comes into the picture. So similarly, I also worked on the same thing, and I created a library, and that library is what I call velocity x. So you can go to velocityx.dev and you can check it out. So what I could achieve, or what I can say about velocity x, is that it also helps you in decreasing your UI code by 40%. Like you have to write minimum to minimum code to achieve the same things. And then it also supports responsive UI, which means that it is very easy to kind of deal with responsive apps using velocity x. So that's what I'm gonna show you a little bit of it. So if you see this example, okay, so if you see this one, so here velocity x offers you a lot of extensions, okay. So like extension methods, not extension but extension methods, I would say. And these extension methods can be based on like context, string, integer, and like widget itself, on different objects. So let's talk about context first. So using context, we access media query, and similarly we can just see all these properties which velocity x offers. Obviously, it all the breakpoints which velocity x uses has been taken from official material design guidelines, and using these breakpoints or using these properties, you can easily like change the behavior of your application so that it can support responsiveness in the best way possible. So for example, there is something called context dot is mobile. So which is mobile is another just a boolean which will tell you if the window is of a mobile or not. So that's very simple way to just identify. Okay, it has a breakpoint behind the scenes which it checks for the current window size, and it gives you that particular thing. Similarly, you can get screen width, screen height without writing much of a code, and you don't have to set the breakpoint by yourself. So there is something called like screen padding which you can get. You can also get orientation, and there are a lot of things which you can do. Talking about things, there are a couple of widgets also which velocity x offers which you can use. So first of all, there is a vx device. So for me personally, when I deal with most of the application, so how I deal with responsiveness is that like there are two ways. First one is either it will be mobile or it will be a non-mobile screen, okay. And second, it can be different sort of screen where I have to support like different let's say UI for mobile. For medium screen, I have to support different thing. So if you have the first case scenario where you just want to have either a mobile screen or non-mobile screen, then you can use vx device, which gives you two properties. One is mobile, and second is web is basically non-mobile. So when you compress or when you adjust the size of your window, if it goes to the mobile breakpoint, then it displays that mobile part of the UI. And if it goes beyond that, then it displays the web part of that whatever you have like shared the information. So let's say if I say on mobile, I just write a text high power on mobile, then it will show high power on mobile. And if I use web property, and if it goes beyond that breakpoint, then it will show high power on web, something like that. So yeah, we can do that. Let's say you don't want that, you want more access to it, you want to get all different breakpoints according to material design guidelines. Then you can use vx responsive, which has extra small, small you can just go inside them, and you can also check the numbers or breakpoints, and there is medium, large, extra large, and all sort of those things, right? So you can check it out. And uh, basically there is a fallback property as well, so if you don't specify any of them, then the fallback one will be used. Okay, so it's pretty easy to use. Just give it a try, and you will feel at home. And this is something which can definitely help you in making your apps very very responsive. And because of the shortage of the time, I cannot demonstrate everything, but yes, you can go to, like, in our application, let me just show you how we are using it. So if you see here, we are using, let's say, context.isMobile, and we are setting the sizes according to this, right? Let's say we have a kind of conditional operator, and we check if it is mobile, then the height should be this, otherwise height should be different. Similarly, we are using it at multiple places. So as you can see in this example as well, we are again checking the same. And we are like we can also use those two widgets which I told you, and there are other widgets as well, which definitely I cannot talk about in this video because of the time limit. But yes, you should check it out. So if you want to check it out, I would suggest to go to this particular YouTube video where I have already demonstrated how you can make responsive application using Velocity X, and I'll be publishing more content or more tutorial on this. And this way, it will be very easy for you to use responsive like design in your application, and you can make it responsive very easily using Velocity X. Or even if you want to use media query and other things, then also it's totally fine. You can go with any of the idea. So now we have done mostly, all the part. We have also made it responsive. Now what comes next? Next thing which comes is deployment. Okay, so now the advantage of cross platform is that when you have to deal with Play Store or App Store, it's a hectic process. It takes time as well to reach to the our final audience or our user base, right? But when it comes to web, okay, we can be ready in just few minutes. And that's the best thing about web, and that's the best thing about Flutter, that you can just go ahead and build a web version of it, and that will also PWA capable. So basically someone can install that app as well. But for that we need to go live, right? And how we can go live? We might have to choose a hosting service, we might have to buy a domain and do all those stuff, right? But that's not gonna that's not what we are gonna do in this particular presentation. But rather we will use something, and it will be deployed in just 5 minutes or even less than that. So let's see what we are gonna do. So we are gonna use Firebase. So I'm also GD for Firebase, so obviously I can talk a lot more about Firebase, but this is something which is really interesting and really nice, which you should definitely take a look at. So when we talk about Firebase, so Firebase has like what you can do. You just have to create an account, or not even an account, you can just connect your Google account, and that's it. And then you have to just create one project, and you can name it anything, doesn't matter what is the name of that project. Name it anything, or whatever you prefer. Okay, and just make sure that the naming convention matches whatever the project you are building. Why I'm saying this? Because it will also give you a domain. Okay, and you probably don't have to buy a domain by yourself until unless you want it, right? So now what you have to do, once you have created a project, then you have to install Node.js in your operating system. So you can go to nodejs.org. Once that is done, then you'll just go to your command line, and you will use Node Package Manager, which is npm, and you can write npm install -g Firebase tools. What it will do, it will install all the Firebase tools into your operating system. And then what you have to do, you have to just write Firebase login. So what it will do, it will basically open a screen or open a window for you in your browser, and it will ask you to authenticate or to sign in with that particular Google account which you are using with Firebase. And once you are done with that, then you are logged in. Okay, so once you are logged in, then for your particular project you have to just write Firebase in it, and it will do all the initialization work for you. And you will see something like this. Okay, and it will ask you if you want to create a new project. Let's say if we haven't created the project by ourselves, then we could create a new project using this particular panel, or we can use an existing project. So we have already created the project, so we will choose that existing project. And once we are done with it, then it will ask us, okay, if you want to, which directory you want to use. Okay, so I want to use a particular directory itself which will be deployed to Firebase, right? So I'll say just like build slash web, but I don't have a build slash web as of now for Flutter application. So what I can do, I can just run flutter build web, and it will like create a directory for me which will be production ready. So which means that I can use that directory for my production level code, and basically it will do perform tree shaking and all that stuff, so that it can be the best performant application, right? So flutter build web, and now we have build slash web folder as well. And that's more or less it, guys. And you can just write firebase deploy, and once you say that, your application will be deployed to your Firebase account. And yes, your hosting part is done almost, and then you will see something like this. So it will say deployed, it will show the size, and yeah, that's it. That's pretty much what you have to do, and that's pretty much what you can achieve with Firebase deployment. So as you saw, like it was just not even 5 minutes, right? Although yeah, because I'm speaking, then it might take that much time, but in general also, when you will try it yourself, then also it takes just this amount of time, nothing more than that. And now your application is live. So if you want, you can check out this application, which is on, let's say, the name, which is the project name which you initially gave, and not the project name, there is below that name there is something where you can change this particular name only once when you create the project. And that after that .web .app, which is a good domain, right? It does not look weird, it does not represent Google or Firebase as a company or brand, right? So if I say, let's say, pkapp.web.app, it's pretty good. It's very fine, and it's also secure. So you don't have to concerned about like buying an SSL certificate or doing some other sort of stuff. And if you want to provide a custom domain, let's say pawan.dev or velocityx.dev, something like that, then also you can buy it and you can easily use it with Firebase. It's all free, and you don't have to do anything until a particular amount or until a particular request limit you reach. So yeah, that's pretty good, and that's pretty easy way to start it. So now we have what we have done. We have created our application, all sort of widgets. We did a couple of cool animations as well, and we used navigation inside it. We also did some API calls to get some real-time data, and then we also made it responsive. Plus what we did, we also took care of mouse events and all those things, and finally we deployed to it. So that's what makes this application complete. And the good part is that we hardly touched like different code for different operating system or different platform, right? We made a single code base, and that is mostly working on all the platforms. And that's what is the power of Flutter. And that's when I say this is the Flutter apps for everyone. Okay, it's Flutter app for everyone. And you can definitely do more than this was just an introduction part of it, that how you can do all the sort of things using just a single code base. So yeah, guys, thank you so much. That's all from my side. And if you have any question, you can reach to me on Twitter, you can reach to me on LinkedIn or wherever. And I'll be publishing more content on this on my YouTube channel, MTech Viral. So yeah, you can check it out too as well. And yeah, keep learning, keep fluttering, and I'll see you next time.